Welcome to Precalculus Concept 28a. Underneath graphs of other trig functions, we're going to study the graph of tangent of x, and there are 3 boxes. So the first question that I get a lot when teaching the graph of tangent is, why does the graph look so funny? And so if you were actually to plug in Desmos or into your calculator or some other graphing utility, the graph of tangent of x, then you would see this on the right hand side here. And notice that I've given you an interval from negative 2 pi all the way to positive 2 pi. And we're used to just graphing things from 0 to 2 pi in terms of sine and cosine. But I gave you negative 2 pi to 2 pi to show you that the graph of tangent is so interesting looking, and it definitely repeats itself. Okay, so let's talk about how we get this. Well, again, it all starts from the unit circle. So on my x-axis, I will have my radian measures, and on my y-axis, I will have my outputs. At 0 radians, notice that the point is 1, 0, and the tangent is the quotient of the y value to the x value. So if I take 0 divided by 1, I get 0. So at 0 degrees, I know that 0 is the output. If I go up positive direction, say to pi over 4, I will get rad 2 over 2 divided by rad 2 over 2, because remember again, this is the y value, this is the x value. So when I divide those two things, I get 1. So where is pi over 4 on the x-axis? Well, if this is 0 radians and this is pi over 2, then it has to be halfway between. So that's why this point is on the graph. If I continue up to pi over 2, notice that I would get 1 divided by 0. Well, 1 divided by 0 is undefined, so therefore there is a vertical asymptote at pi over 2. Okay? As I continue on, if I went to 3 pi over 4, I would get a value of negative 1. So here's 3 pi over 4, and here is a value of negative 1. So the graph just repeats itself over and over again, just like this. So it's interesting to note that the tangent has a period of pi, meaning that this distance from here to here is how long it takes to complete one full cycle, and there will be a period of pi. And all we really need to be responsible for is the stuff that happens in between one full cycle of tangent. So this is how the graph occurs, and again, it stems back to the unit circle, so hopefully that clears up as to why the graph looks so funny. Okay, box number 2. I'm going to show you how to graph a basic tangent function as a quick sketch. Remember, we need to be responsible for graphing sine, cosine, and tangent as quick sketches in no time at all. So to graph the basic tangent function, you want to give yourself, of course, a coordinate plane and set yourself up for success. You want to go between negative pi over 2 and positive pi over 2. Why these points? Because you'll recall that there are asymptotes on either side of pi over 2 for the basic tangent function. So we want to just know what's going on in between. We learned from the box above that 0, 0 is a point on the graph. I like to go ahead and put in a point in between, which of course is pi over 4, because it's halfway between 0 and pi over 2. And I know the output will be 1. So at pi over 4, I know I'll have a value of 1. I'd also like to go in the negative direction of negative pi over 4, and I would have an output value of negative 1. So therefore, pi over 4 negative 1 would work. Now if I were to fill in all the points in between, I would have this beautiful little sketch that would look like this. So this is what we need to be responsible for a basic tangent function, okay? Then the question becomes, well, what happens if we start moving this tangent function around? Like, what happens if I put a 2 right in front of that tangent function? Well, take a look at this. I have a nice, pretty, pre-drawn graph for you. The red graph, of course, is the one that we just did. Notice that it's between negative pi over 2 and positive pi over 2. Notice I have the point pi over 4, comma 1, and negative pi over 4, comma negative 1, just like I do over here. But the orange graph is the graph of 2 times the tangent of x. And so notice that instead of 1 comma pi over 4, I have the point 2 comma pi over 4. So that 2 out in front is going to vertically stretch my tangent function. Notice I also have the point negative 2, negative pi over 4. So right now I want you to take a guess. If I gave you the equation y equals 7 tangent of x, okay? Could you tell me one point that would be on there, one positive point that would be on the graph? Okay, box 3, I'm going to show you how to graph tangent functions of the form a times the tangent of bx minus c. We first need to identify what all the pieces do, okay? The a out in front is going to be your y coordinate at exactly 1/4 and 3/4 of the way through, and I'll explain more about that. In this case, over in the example, our y-coordinate is going to be 2. This part right here that's inside your parentheses, this is going to tell you where 2 consecutive asymptotes are. So what we do is we place this stuff in between negative pi over 2, less than or equal to whatever happens to be here, bx minus c, less than or equal to positive pi over 2. You may be wondering why we're choosing negative pi over 2 and positive pi over 2. And you'll recall in box number 1, we saw that there was one full cycle of tangent that falls in between negative pi over 2 and positive pi over 2. So we just adjust by solving this inequality. For us over here in this example, we would have negative pi over 2 is less than or equal to 1/2 of x, which is less than or equal to positive pi over 2. Okay, so what we're going to do is we're going to now solve this inequality for the value of x. I do this by multiplying everything by a value of 2. So I get negative pi less than or equal to x less than or equal to pi. And that right there tells me on where I can find two consecutive asymptotes. So if I draw a coordinate plane here, I would go over to call this negative pi and call this positive pi. And I know that in between here, I'm going to have 2 consecutive asymptotes. So this is my left endpoint, this is my right endpoint. That means that halfway in the middle, I'm going to have a 0 factor. 1/4 of the way on either side, I'm going to have half that distance, so this is going to be pi over 2, and the coordinate that I would get out is the number 2, because it told me right there as the a value. So that means that negative pi over 2, I would have negative 2, and that point would be down there. So therefore, this is what my graph would look like as a quick little sketch. We will practice more of those in class, but it's pretty straightforward as long as you know a few ideas about tangent.